mathgoodserve.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 1 to 5 of the Algebra 2 Common Core New York Regents exam for June 2017. Alright, let's take a look at question number 1. It reads, the graph of the function p of x is sketched below. So we have this function sketched below. Question, which equation could represent p of x? So we have 4 options here. So let's start out by writing the formula that's going to guide our problem solving process. Okay, so the formula we're going to use is as follows. So let's say if z1, z2, and z3 are zeros of a function, okay? Let's say the function is f of x. Then the function can be written in a unique form. In the factored form, the function can be written as f of x equals x minus the first 0 times x minus the second 0, z2 times x minus the third 0, z3. Okay? So this is the formula that we're going to be using to guide our problem solving process. Okay, so let's go ahead and start by writing down what our zeros are. The zeros are basically the roots of the related equation. Where does this function have an output value of 0? That's what the 0 is, okay? So this is the first 0. z1 is negative 3. The second 0 is right here. z2 is positive 2. And the third 0 is right here. That's z3, which is positive 3. Okay, so from the graph, let's write that down. From the graph, the zeros, or you can also refer them to the roots of the equation. The zeros are z1 equals negative 3, z2 equals 2, and z3 equals 3. Now, how can we write the polynomial function with the zeros? All we just have to do, let's replace the z's with x's. We have x equals negative 3, x equals 2, and x equals 3. Now we're going to set each solution to 0. Okay? Now to accomplish that, we'll just simply add 3 to both sides in the first equation, subtract 2 from both sides in the second, and subtract 3 from both sides in the third. Okay, so we're going to have x plus 3 equals 0, x minus 2 equals 0, and x minus 3 equals 0. Now we're going to use the reverse of the zero product property, okay? We're going to find the product of these polynomial factors. Now since they're all equal to 0, what will we get when we multiply the polynomial factors? X plus 3, x minus 2, and x minus 3. They're going to be equal to 0. Okay? Now let's multiply x plus 3 and x minus 3. And then we'll leave x minus 2 alone. Okay? The reason being that if you look at the options provided, we have potential solutions that have just x minus 2 as a factor that's not simplified, okay? So that's why I'm leaving x minus 2 alone first to see if we can get a match, and then we can go from there. Okay, so what happens when we multiply x plus 3 and x minus 3? Well, this is a difference of squares. So when you expand this, x times x times negative 3, and then you go positive 3 times x and positive 2 times negative 3, you will end up with x squared minus 9, because the positive 3x and the negative 3x you get in the center, when you FOIL it out, they both cancel out since they're opposites. Okay? So we have x squared minus 9 times x minus 2 equals 0. This is the polynomial equation. The related function is f of x equals x squared minus 9 times x minus 2. We can see that our answer is option number 1. Okay, x squared minus 9 times x minus 2. Alright, let's take a look at question 2. It reads, what is the solution to 8 times the quantity 2 raised to the x plus 3 equals 48? Now, there are certain things you want to recall. Actually, one main thing you want to recall concerning the properties of logarithms that will enable us to solve this exponential equation. Okay? And what you want to remember, let's write it down. You want to recall that if you have a logarithmic term that's a power, you can power down that exponential value. Okay, so you can just basically power down that power right here. This x can be powered down to give you x times the natural logarithm of a. Okay, so that's a property of logarithms that we're going to be implementing in solving this problem. Okay, so we have 8 times 2 raised to the x plus 3 equals 48. Now remember that anytime you're solving an equation where the variable is an exponent, you will have to use the inverse of exponential functions to solve it. So the goal first is to isolate the term with the exponent that has a variable, which is 2 to the x plus 3. To get it isolated, we'll first have to get rid of that 8 in front, okay? So this can be accomplished by dividing both sides of the equation by 8. When you do that, you get 2 raised to the x plus 3 equals 48 over 8 is 6. Now to get rid of, or to power down this exponential value, we're going to take advantage of this property of logarithms that we wrote here. Okay, so to power this down, what we're going to do is take the natural logarithm of both sides of the equation. Okay, so we take the natural logarithm of 2 raised to the x plus 3. That's on the left side. And then on the right side, you're going to take the natural logarithm of 6. Okay, why did we do this step? Well, if you look at what we stated earlier, we did this because it enables us to power down this exponential value. Okay, so instead of the x being a power, it now comes down to become x. Let's change the color there. It becomes x plus 3 quantity times the natural logarithm of 2, and that's equal to the natural logarithm of 6. Alright, it looks much better now. It's easier for us to get x isolated. So now what we're going to do next is we're going to proceed to get x by itself. Okay, since x is grouped with positive 3, we need to get rid of natural logarithm of 2 first. We'll do that by dividing both sides of the equation by the natural logarithm of 2. Okay, so that gives us x plus 3 equals the natural logarithm of 6 divided by the natural logarithm of 2. Final step, we will simply subtract 3 from both sides of our equation to give us the final result. X is equal to the natural logarithm of 6 divided by the natural logarithm of 2 minus 3. Okay, and there goes our final answer. We can see that the answer for question number 1 is the answer to question number 2 is option number 1. Alright, let's take a look at question 3. It reads, cheap and fast gas station is conducting a consumer satisfaction survey. Which method of collecting data would most likely lead to a biased sample? Okay, so one thing I want to note concerning bias is that the more random a selection process is, the less biased the sample is going to be. Okay, so let's write that down real quick. So you want to recall that the more random a selection is, the less biased the sample. Okay? Alright, so in this particular problem, we're looking for which one is most likely to lead to a biased sample. So we're looking for the selection process that's least random. Okay, that is not even random again. That involves some kind of pre-selection in the in the selection process. Okay. All right. Now let's see what we have here. The first one, we have the interviewing every fifth customer to come into the store. So they just selected every fifth customer. Is there a particular pattern there? The answer is no. Since it's every fifth customer, it doesn't matter where they're coming from, just every 5, this is random. Okay? Because you don't know who is going to come into the store when you count every 5. Question 2. Option 2, it says interviewing customers chosen at random by a computer at the checkout. So you see the word there, random? This is a random selection process that clearly tells us that this is random also. Question 3, interviewing customers who call an 800 number posted on the customer receipts. Think about this for a second. When customers call, are they randomly deciding to call, or is there a specific reason that they're calling? Customers who call the 800 number on the receipt, there has to be a reason why they're calling. It could be that they are dissatisfied for some reason or the other. Okay, so this process of collecting data is known as self-selection. Okay, so in this particular scenario, it is not random at all. This is self-selection and is not random. Okay, so since it's not random, it's going to be biased. So this is going to be the correct answer. Alright, now if you look at option 4, it says interviewing every customer who comes into the station on a day of the week chosen at random out of a hat. So that indicates randomness in the selection process. So this one is not going to be biased. Okay, so the answer for question 3 is option number 3. Alright, let's take a look at question number 4. We are simplifying complex terms here. The question reads, the expression 6xi to the third times the quantity negative 4xi plus 5 is equivalent to. So something you want to remember concerning simplifying powers of I. Okay, so one thing to note is that powers of I greater than 1 must be simplified. Okay, it must be simplified. So the question is, how do you simplify powers greater than 1? Remember the pattern, so let's recollect that. So you want to recall the rule for reducing powers of I. Okay, so if you have I is I to the first power, so this does not have to be reduced. you have I, it's okay, just leave it alone. If you have I squared, that power is greater than 1, it has to be reduced. I squared is the same thing as the square of root negative 1, which is just negative 1. I to the third is the product of these two, which yields negative I. I to the fourth is I squared, or I times I to the third. Whichever way you do it, you will end up with positive 1. And this pattern wraps around. What does that mean? If you go to I to the fifth power, you circle right back to I to the first. I to the sixth power is the same thing as I to the second. I to the seventh power is the same thing as I to the third, and I to the eighth power is the same thing as I to the fourth. So whatever the power is, just divide by 4, and whatever the remainder is, just place it in this list right here, and you can determine the correct simplification value. Now with that in mind, let's go ahead and solve the problem. Now we have 6 x I to the third times negative 4xi plus 5. We have a parenthesis here which indicates that we have to do what? We have to distribute this term on the outside to both terms on the inside. Okay? Alright, if we do that, we're going to have the number times the number. 6 times negative 4 is negative 24. X times x is x squared. And then I to the third times I to the first power, there's a 1 there. You add the exponents when multiplying numbers with identical bases, right? So this is going to be I to the fourth. 6xi to the third times 5. 6 times 5 is 30, so we have 30xi to the third. Now, which terms do we have to simplify here? Which values? I to the fourth, the power is bigger than 1, so it has to be reduced. I to the third has an I with a power that's bigger than 1, so it must be reduced also. Okay, so if we simplify this, we have negative 24x squared times, let's see, I to the fourth is right here. I to the fourth is just 1, so I to the fourth reduces to 1. And then we have plus 30x. What does I to the third reduce to? I to the third reduces to negative I, so just put negative I here. And close it. Now we can simplify further, okay? So we have, if we multiply this out, this becomes negative 24x squared. This minus times plus. Whenever you multiply signs that are different, remember it's always going to be a minus. Minus 30xi. The final answer for question number 4 is option number 2. Alright, let's take a look at question number 5. Question 5 reads, if f of x equals the absolute 3 times the absolute value of x minus 1, and g of x is equal to 0.03x to the third minus x plus 1, an approximate solution for the equation f of x equals g of x is. So let's start by reminding ourselves what the meaning of a solution to an equation is. Okay? So recall the definition of a solution. Okay? So in this particular case, a solution to the equation, let's see, two functions, f of x equals g of x, is the what? Is the x value that does what? That satisfies the equation. Okay? Now, if you take a look at the options that we have here, you notice that we have a value here, and we have an ordered pair here, 3 and 4. 3 and 4 are a combination of x and y's. These are not solutions, okay? Not x values, so they cannot be considered solutions. These are ordered pairs. So it has to be one of these two that's the specific x value that satisfies this equation. Okay, so what we're going to do, there are two ways you can do it. You can just plug in these values in here and see which one satisfies this equation, or you can graph. Okay, I'm going to do the graphing option so I can show you how to solve this graphically. Okay, I'm going to be using the TI-84 plus to help us graph the problems, the functions, and determine what the intersection is, which is the solution. Okay, press Y. Let's graph the first one, 3. Absolute value, we go to catalog, x minus 1. That's the first function, f of x. The second function is 0.03 x to the third minus x plus 1. Alright, so there goes the two functions. Let's graph it. I manipulated the window, so let me zoom it to the standard window. Okay, so when you have your standard zoom window, this is what it's going to look like. Okay, so we have two intersections here. One looks like negative value, -1. One looks like a decimal value. And it looks like there might be another one here. Okay, but just looking at what we have here, we can easily determine if this is the answer or not. So let me show you what you can do. Let's just zoom in first. So if we zoom in, I want to zoom into this 0 right here to have an idea as to what's going on. What do you think this intersection, the x value of this intersection is? If we trace it, we see that it's 0.5-ish. Okay, if you want to find out exactly what it is, let's calculate what it is. So second function calculates the intersection. Press 5. Enter, guess. Make sure your cursor is close to the intersection point you want to calculate. So it's 0.5. So since the positive solution is 0.5 and not 1.96, 1.96 is somewhere here, that automatically tells us that the answer should be option 2. It cannot be this one. Okay? So let me show you how to know for a certainty that this is the correct answer. What we're going to do is, let's zoom standard again. You can zoom out to get a better view of the point of intersection here, but to take the guesswork out of the equation, I'm going to take a look at this graph and pick a window that should work. Okay, so how about we go from, to the left is this intersection here. We can go from, for our x, we can go from -2. How far to the right do we want to go? I want to pick a number that's bigger than this particular x value. Okay, so let's go to the window. The minimum x is how far to the left you want to go. Let's put -2, or let's just make it -3. The x maximum, I want a number that's bigger than this particular solution here, which is 12. Now, how high do I want it to go and how low do I want it to go? If I look at the graph, it goes as low as maybe -3 should be good enough. How high can I go? To figure that out, just go to the table and look at 11 or 12. 12 is 35, okay? Or 40 for the second one. So let's just use 40, okay? So we have 40 as our maximum y, and our minimum y we set to use -2 should work. So let's go back to the window. So x min is -3, x max is 12. For the y, the minimum is -2, and then the maximum is 40. Alright, so let's graph it. Now let's calculate what this intersection is. Calculate intersection You can easily see that it is going to be 11.29, but I gotta show you so you see for sure that what I'm saying is correct. First curve, second curve, guess 11.29. That's perfect. So that is the solution that we're looking for. The correct answer to question number 5 is option 2. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is extremely valuable to us. If you have any questions or comments about what we covered in this presentation, just include it in the comment section below, and we will be more than glad to support you. Don't forget to subscribe to our channel for updates to other tutorials such as this. More clips can be found on mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.